Hello and welcome to my messy desk. I just wanted to show you the Burn Baby Burn. I promise that's the last time I'll ever sing board. Yeah, this is a new project that I've been working on for a while. I'm going to stick some of these up on my Tindy saw. Basically, it's a little Nichrome burner. There's a little Nichrome coil here and a MOSFET that we can control via this S pin with a pulse width modulated signal from a GPIO for any microcontroller. I've got a little example. I've got a couple of examples on the repo that are done in MicroPython using a Raspberry Pi Pico, and I'll set this up and show you how it works in a minute. But what it's for is for basically cutting bands. So you could cut like a rubber band, or you could cut some fishing line, and that could be used as a release mechanism for all kinds of things, from antenna deployment to dethermalizing free-flight planes to, and what I'm particularly interested in, using them with a kind of loop round a parachute shroud lines, that's hard to say, so that you can have a parachute reefed and then cut the reefing away and deploy the parachute fully. Also, these things get used in like high altitude ballooning. Honestly, I need to put my teeth in. It's ever since I sang that line. Anyway, yeah, you could use them on a high altitude balloon to like as a cut down system. Yeah, and they could be driven by pretty much any microcontroller, as I say. I'm going to supply them with some header pins. You might want to put these headers in, or you might not. You might want to just wire directly into the pads, because that's going to keep it a lot more kind of compact. But for prototyping, like putting the header pins is quite handy. But then there's an extra header pin here, which is there's a little pad, and all it is to create a little hook so that you can hook a band or your nylon cordage round. So yeah, I'll cut now to showing you a setup that the code I'm supplying on a little repo. Okay, so I've got a little setup here, so you can see the Burn Baby Burn is here, and then there's a little band. It's a silicon, it's about the size of a loom band, but there's some silicon bands that I have. Yeah, it's just hooked over here just to kind of hold it over the burner. This is the battery that's supplying the Burn Baby Burn board. It's a e-cig, salvaged e-cig vape battery. This is a Raspberry Pi Pico. This is one of my pull pin switches, which I sell on my Tindy shop. And then this is one of those little BGA, Pi Moroni's brilliant little BGA RP2040 sort of Pico type board, just to show that you wouldn't have to have this enormous setup. You could do this with a much smaller kind of microcontroller. So yeah, it's set up that when I pull this pin out, there should be a delay of 2 seconds, and then the coil will fire for 4 seconds, and the band should pretty much go immediately. So pulling the pin, and there we go. You can see that burnt through pretty successfully, pretty much straight away in the first sort of few milliseconds of the device heating up. So yeah, it's just an example of how it could be done, of course. There's a nice hole in the back. I've just used a header pin to just kind of clamp it down, but you can use a nice hole at the back to put maybe like a Kevlar thread going round to sort of encapsulate your system, and then a band on the last bit. Yeah, there's all kinds of ways that I could imagine these getting set up. So yeah, they're going to be on my Tindy shop. I'll put the link in the description. Thanks very much for checking them out. Oh, and all the design files and a couple of Python examples are on the repo, which I'll links in the description. And massive thanks to Ayla for helping me out with some of the interrupt code for this example. So yeah, lovely stuff. Thank you very much. Thanks for watching.